Okay, so in this video, I'm going to continue showing you the solutions for the items in the assessment 2 of topic 3. Okay, this expansion and factorization of algebraic expressions. So we are now in 2f. It's 2f. What we want to factor is k squared plus 8k plus 16. Okay, so this is a trinomial expression. There's no common factor that you could see. K is not a common factor. You only have the second term and the third term with a factor of 8, and this is just 1, so 8 is not a common factor. In most cases, trinomials can be factored in this way. So you will have two binomial factors, and you have to play with the factors of k squared and 16. The first factors of the binomials will come from the k squared, and this will be k and k, because k times k is k squared. And then the factors for the second terms will come from 16, and that's we could think of 4 times 4, and then that's 4 and then 4. And this must be positive and positive to create a positive 16. And then to check whether these really are the factors, the correct factors, we have to consider that the middle term should be 8k. And one way to check that is to multiply the inner, that's 4k, and the outer. If the sum of the two values, the two resulting values, is equal to the middle term, which is 8k, then the factors that we have are the right factors for the trinomial. Hence, k squared plus 8k plus 16 is k plus 4 times k plus 4, and you can write this as k plus 4 squared. Okay, so another way of factoring this is if you can recognize that k squared plus 8k plus 16 follows the form a squared plus 2ab plus b squared. And if it is of this form, then the factored form is simply a plus b squared. So how to use this method is you find the values of a and b. So the a is k, in this case the a is k, and then the b is the square root of 16, which is 4. If the 2 times ab, which is 2k times 4, is equal to this expression, the middle term, and that means you could simply factor this as a plus b squared. And if we check, 2 times k times 4 is 8k. So factoring k squared plus 8k plus 16, you could already have set up parenthesis squared, and the first term is basically the square root of k squared, and the second term is the square root of 16, which is 4, and then this is plus. Okay, and you have arrived at the factored form immediately. That is, if you know how to identify if the given expression follows an a squared plus 2ab plus b squared form. Now to make that easier to understand, I'll give you one more example. Suppose this was, or you were given k squared plus 10k plus 25. So first note that the first and the last terms are perfect square values. K squared, since the exponent is even, so it's a perfect square. 25 is a perfect square number coming from 5 squared. So the square root of k squared is k, the square root of 25 is 5. Now if you double the product of these two and it equals the middle term, then the factored form is simply a binomial squared. And if we check 2 times k times 5, that's equal to 10k. Therefore, k squared plus 10k plus 25 is simply k plus 5 and then square. So I'm just giving you an alternative way of factoring trinomials, especially those under we consider as special cases. They come from a plus b square or maybe a minus b square. Okay, but again, by default, you could always use the first method that I have shown you, and for sure you will also get the correct factored form. Let's take a look at letter G. Maybe this number 2G is somehow connected to 2F. In 2G, you have y squared minus 16y plus 64. So if you're familiar with the perfect square numbers, for the y squared, definitely that's a perfect square because of the 2. 64 is a perfect square coming from 8 squared. And following the same idea from 2f, the square root of y squared is y, the square root of 64 is 8. And if I double this is equal to 16y, which is actually the middle term. Now in the previous example, it was a plus middle term, this time it's a minus middle term. So it's simply the counterpart. So instead of a plus b squared, this is coming from an a minus b square expression. So to factor y squared minus 16y plus 64, so this will be parenthesis square, the first term to be the square root of y squared, and the second term will be the square root of 64, which is 8. And this is minus because you have an a minus b squared format. You see, so we have spotted an expression that can be easily factored by, um, by having the a minus b squared form. Okay, now suppose you don't want to use that method, so we have y squared minus 16y plus 64. You can always start with this. You have two parentheses, then y and y for the y squared, 8 and 8 for the 64, and then minus minus, and then you just have to check whether the sum of these two will equal to the middle term. So basically the ideas are the same, except that they are, once you spot that, an expression is special, you could immediately get its factored form. Okay, so two ways. You can pick whichever you find easier. Okay, next, letter H. So in letter H, we have z squared minus z minus 12. If you take a look at letter H, it is no longer of that type from 2f and g because of 12. 12 is not a perfect square, so we cannot force this to be something squared in which this is z and this is a whole number. Maybe an irrational number, but that's not how we factor the expressions here. We have to make the numbers rational numbers, fractions or whole numbers, but not square roots. Okay, so since the last term is not a perfect square number, then we could proceed with the traditional way of factoring the trinomial. We have to have the factors of z squared as z and z, and then we have to think of factors of 12, considering that the difference is negative z or negative 1. Now we have several options. Maybe it's a 6 times 2, it's a 4 times 3. So from these combinations, only one can have a difference of 1, and that is a combination of 4 and 3. So we place 4 times 3, and we just have to properly select which one is the negative number and which one is a positive number, because since the third term is a negative 12, then it's either it's a negative 4 times 3 or it's a 3 times negative 3 times 4. But since our goal is to have a negative z, that means a higher number should have the negative sign. So we have to pick the negative 4 times 3 combination. So this is z minus 4 and z plus 3. So the factored form of z squared minus z minus 12 is z minus 4 times z plus 3. Okay. Next, we have letter I. So this is now I. In letter I, we have x squared plus 11x plus 30. So this time 30 is also not a perfect square, so we have to resort to the usual method of factoring expressions, trinomial expressions. So we select x and x for x squared, and then we have to pick combinations of 30 leading to the sum 11. So we can think of 6, 5, 15, 2, and then 10, 3. But here, you could already see that the 6 and 5 is the right combination because 6 plus 5, the sum, will be equal to 11. So the factored form of x squared plus 11x plus 30 is simply x plus 5 and x plus 6, or you can interchange that as x plus 6 times x plus 5. So any of the two is correct. Okay, and then letter J. In letter J, you have 3n squared plus 8n plus 5, and then again, 3 is not a perfect square, 5 is not a perfect square. So we start by thinking of what are the factors of 3n squared. So we could think of that as 3n times n. And then we select factors of 5. Now 5 has only one combination. It's 1 times 5. So all you have to do is to place the numbers properly. Like, is the 1 supposed to be here and 5 supposed to be here, or the other way around? Like the 5 should be here and the 1 should be on the other binomial. So how do you check? So first, we have a positive 5 and positive 8n. So it means same. You have to have the numbers with the same signs, and it should be the sign should be positive. So positive and positive. So how do you check which of the two is the correct factored form? We do the outer and the inner. So this is 1 times n is n. 3n times 5 is already 15n, and that's already beyond or above the value 8n. So that means most likely it's the second option, and we could also check that. So this is 5n and this is 3n. The sum of 5n and 3n equals 8n. So that means the factored form of 3n squared plus 8n plus 5 is simply 3n plus 5 times n plus 1. Okay, so there you go. You have seen how to factor different types of trinomials with letter F and G to be or letter F and G are expressions coming from a binomial square, one from a plus, see, a plus, and then the other with a minus. We have two examples here with different cases, and then the other three problems is for you to is for me to test whether you know how to come up with the proper combinations of numbers so that you could factor the expression properly. Okay, and then yeah, that's same for letter I and letter J. Okay, so that's for the second set of factoring. So that's number 2F to number 2J.